quiz, so I can go ahead and activate that. Where's that at? In D2L. Yeah, since my other class is not in D2L, sometimes I forget to go into both places. Okay, D2L, quizzes 4. Quiz number, thought I fixed, that's 5, chapter 4. Yep, there it is, inactive. Okay, edit, restrictions, active, the start date of, where is that at? January, into March 6th, right now, and okay, then, oh, forgot to turn it off, sorry. Oh, that's my husband, I hope it's not a big deal. 9th at 11:15. Okay, so you have till, oops, that's the wrong date. What's going on? February, March. Be March the 10th at 11:59. So you have till Monday night to take it, the quiz, since I didn't put it up over this past weekend. Or, I mean, since Tuesday. Okay, I've been so mixed up with days this week. I've been a whole day ahead all week. Now I'm fine. All right, so what I wanted to do is first look at a couple of the quizzes. And anybody else, Tristan's not in here. He told me he put his and I didn't find his test. John's not here either. I didn't find his test. Somebody else. Morgan, is Morgan here? No. Okay. Those were the ones that for sure I just went and looked for their test. Okay. One that I did grade, Roberts. I started at the bottom this time and went up because those guys always get the last grade. So I got up to yours, I think, when I stopped before class. So we're going to take a look because his, and we're going to see, y'all can ask questions then when we look at his to see if you did it a little different, if it's correct or not. Can y'all see that is good on there, or do you want the screen down? Screen better, Kat, or is this okay? That's good? Okay. All right, so let's go to, why are my emails jumping? Okay, so let's go to where the Google Drive and Roberts was RM. I wouldn't do his, but he got 100%, so that's pretty good. I don't think you can do any better. There was some things that I would have changed a little bit that we're going to talk about here. Let's look at his pseudocode first. And in his pseudocode, he named all his variables, and he didn't use, some people use constants, like here, you could have used a constant, right, for high GPA and minimum. Yes. Put it what now? Oh, the screen down? Okay. I don't know if it's a screen. I'm going to make it larger. Does that help? So not as much of a glare. Here, let me see if I can increase the size here. How about that? 125. I can actually go 150 with that. Is that better? Okay. So in his declarations, there was the name. The study is what he called your field, your degree, major field, GPA. And then he would move a value into a variable called out to print out. Oops. Oh my goodness. What happened there? But you didn't have to do that. I don't know why that's doing that. Okay, so where did that go? I don't know. I moved my mouse a certain way and it did it. RM test. But you also notice here the 5 points. This was how I wanted your zipped file. Most of you did that. There was a couple people didn't. So that was worth 5 points to have these 2 files in a zip file. Let's see if I can get that up again. Then I'll have to. Oh, I guess it was making me, for some reason. That's strange. Sign in now. I don't want to use Acrobat Pro. I just want it to open. Yeah, I bet I can do. Yeah, but I usually don't. Still have to. I should have the reader on there without having to open that way. That's the default. Here's preview. It should let me open it in there. Okay, so here's my view. Zoom. Okay. Okay. So we could have also used what I was saying is a constant, which I wanted y'all to do that, so I didn't, but I didn't go ahead and count off on it on this time. But I wanted you to use, like, here would have been like a maximum GPA constant and then a minimum GPA constant, so that up here you could have used those constants. But here's the way the logic was: if GPA is greater than or equal to 3.5, then output Dean's List. And actually, then there's an end-if there. But when you're using an else, you wouldn't put an end-if here, because you only have this else goes with this if, right? So the end-if should have actually been down here at the bottom for that one. Okay, but this was pretty close, so I counted the pseudocode right. Else, if GPA is less than or equal to 2.0, then output academic probation. Else, so there we've got another end if that we don't need. Else, if GPA 2.0 or GPA 3.5, then output nothing and end if, and then there's where his output is. Now, there's another way you could have done it with less if statements. Who did it differently where you did?
I think I might have done it with only an if and an else if.
That's right. Okay, that's a way, and that would mean you didn't test this, right?
Right.
Because that's unnecessary. Most people do it, but remember the problem in our exercises at the end of the chapter where it said, let's see, let me find the end of chapter 3. There was one problem that we talked about that had an extra part that you didn't need to address in your output. That was the one number 3 on page 111, when we were saying if it's less than a year, they get a newlywed gift. If it's greater than a certain number, married 40 years or more, then it's an anniversary package. And then at the end it said if they're married between 2 and 39 years, don't do anything. Well, that's what this was. Don't do anything if the GPA is greater than 2.0 or the GPA is less than 3.5. So it did work the way Robert did it. It's just that you don't need this one here if you set it up right. Let me look at, let's look at Amelia's. I didn't grade it yet, but let's look at yours because you did it.
I did a flowchart.
Okay, so yours is here. Oh, there again, that's doing that. I'm going to have to say, I guess it's wanting to update, and I don't want to take time for it to update. So if I go open with preview. Okay, so here, what she did was her input has a high grade, so she used constants. Low grade, here's her input, student name, major, and grade point. If grade point is greater than high grade, if yes, let me see if I can make this bigger this way. Okay, if grade point is greater than high grade, and this should be the yes path, if it's greater than high grade. Now, you didn't say greater than or equal to. Is it supposed to be inclusive?
From what I could tell, it didn't look like
No.
it was inclusive.
Okay. That was what I couldn't remember how it was. Okay, so if it's greater, come on, now where'd it go? Here it is. If it's greater than output dean's list, then else, if grade point is less than low grade, because you couldn't just say else, or it would get everything below 3.5, right? So you had to say else if grade point is less than low grade, output academic probation, and end. Okay, so now in her JavaScript, she had to go ahead and say output, name, all of that, right? So in these outputs, you could have also had a box here that said either at the top or somewhere it would say output student name and major and GPA, right? And then do this test, and then it would either output academic probation or dean's list or nothing, right?
I don't think I remember it asking for all of that information
On the let's see. Okay, hold on. Let's see what the problem. Yeah, I should have read had us read the problem first. Okay, so the problem says Pastoral College is a small college in the Midwest. Design a flowchart or pseudocode for a program that accepts a student name, major, field of study, and grade point average. Display a student's data with the message. Okay, did you do it in your JavaScript?
No.
Okay,
story problem. You look for the numbers and figure out.
Yeah, figure out. Okay, so when we run, let's go to JavaScript, open with Dreamweaver. Let's see what we do here, what her JavaScript looks like. No, I don't need that. Oh, I guess it's going to make me do that before it even lets me get to Dreamweaver for some reason. Okay, I'll open it with Text Wrangler. Here we go. Open with Text Wrangler. Okay, so in this one, let's see if I can zoom it or not. No, it's probably going to make me preferences go a little bit bigger. Appearance, where y'all can see it is, yeah, here it is. I remember that I had trouble with this, like 24, select. Okay. Now it should have changed it. Huh. There we go. I don't know how much it changed. Oh, it changed over there, but not here very much. Okay, let me go again. Preferences, what am I doing? This is I thought that should have been the editor. Regular 18. There we go. All right, so now that's better. Okay, hopefully I can see it now. So all of this is set up right. Student name equals prompt, major equals prompt, grade point equals prompt. Now, I had some students that are still confused on the input, that you can't put input like you did in your pseudocode. You have to say a variable name is equal to the prompt. So there's 3 inputs up here, so we had to have 3 prompts. Then we did this to make sure it was numeric, grade point times 1. If grade point is greater than high grade, then document.WriteLine, you are on the dean's list. Else, if grade point is less than low grade, document.WriteLine, you are on academic probation. Okay, so if it's not one of those 2, so it told you to test it with, let's see, told you to test it with, let me tell it to go to Google Chrome, with first 3.5, so it should say
Please enter your name.
Oh, sorry. DW, enter, CS. Now GPA 3.5, which should come out what?
Nothing.
Nothing, right? Because Dean's List has to be greater than 3.5, right? Okay, so I'm going to run it again. This time, I'm going to say 3.8. So it should say Dean's List, right? You are on the Dean's List, okay? Run it again with 1.9. Yeah, okay. CS, okay. And 1.9. You're on academic probation. Okay, so those all work right, but she should have put student name, major field of study, and then Dean's List or academic probation, right? That's the only thing that's different. Anybody have any questions, something you did that you want to know if it was right or not? Right.
Well, for mine, that last else if I had,
Uh-huh.
when I was running the program without it,
It didn't work right?
it had an undefined when it was in between.
Okay, so let's see how we can fix that. Robert, here, open with text wrangler. Okay, so here you had name equals prompt, study equals prompt, GPA, if GPA is greater than or equal to, so you assume, let's see, what did it say up here? Dean's List, if the student's grade point average is above 3.5. So that was one error on there that I didn't catch because I was grading it in a hurry. Let's see. Where'd my text wrangler go? So that would change. So we would change that to take the equal sign out. Else if GPA is less than or equal to 2.0, output that. So you're saying if you didn't put this on there, okay, well, let's run it this way first. Name, DW, okay, CS, okay, and 3.5. And the way your logic is, it should say Dean's List. Yes, it did. Okay, so because he put an equals in there. DW, okay, CS, okay, 3.8, okay. All right, so then the last one is DW, CS, and 1.9, and that did work. Okay, so now if we go over to Text Wrangler and we take the equals out, and the equals out here also, and then we should be able to take this off, but there's probably else if I think you have to have one more bracket. What'd that say?
Unmatched.
Okay, so I don't need it. Okay, so document.writeLine. So here's where you said save as. Let me put it somewhere else. Let me just put it on the desktop for now so I don't mess with yours that's out there. Okay, so now if I go there, it's not looking at it as an HTML file. There it is. Okay, please enter your name, DW, okay, CS, okay. Okay, now it should do this one with nothing now. That's why it says undefined, because you're using a variable out. See, if you put the actual message in quotes, but that works the way you did it also, is to get rid of it. But if you initialized out up here to say equals, I think that will work also. Let's see, file, save. So if we put 3.5, yes. So does everybody see what we did? He put his extra if in there at the bottom because he couldn't get this not to come up undefined. Well, the reason it was undefined is that if you don't put anything in out, then it's undefined. So if when you initialize a variable that that there's a possibility that you're not going to put a value in it, then you have to initialize it with a value. Okay. Corey, did you do something different? Or do you work it like this pretty much?
I did the prompts like that, and then, yeah.
Pretty much like that. Okay. All right. Anybody else have any questions about the way you did it or want to look at one? Okay. All right. So next what we're going to do is we're going to look at a review of what we covered on nested loops. Did anybody look already at the video, the author's video? Anybody look at those? That's what I thought. So I'm going to look at them in class. We're going to look at them because they're so short. But this will kind of be a review of what we did a week from today, last Thursday, because we had the test. Okay, so if I look up here, all of these are in your D2L if you don't want to have to download them. But mine are, oops, up at the top. Chapter 4, and the one that we're going to look at, not that one, nested, that's what I want. Okay, so this one, nested loops. Let's see if I go the whole thing. I hope y'all will be able to hear it.
Hi, this is Joyce Farrell. Let's look at nested loops.
You hear it?
When you have two loops and you remove the body of one and insert another loop, then you have nested loops. Let's look at a savings application. Suppose that you're paid twice a month, and suppose that you decide to save $50 from your next paycheck. The next check, you want to save an additional $5 or $55. Then you want to save $60, $65, and so on, increasing your savings amount by $5 every paycheck. How much will you have after a year? You want your output to look like this. After month 1, paycheck 1, you'll have $50. After month 1, paycheck 2, you'll have $55 more for a total of $105. After month 2, paycheck 1, you'll have $60 more for a total of $165. And after month 2, paycheck 2, you'll have $65 more for a total of $230. Then $70 more, $75 more, and so on. You can declare some variables, month to hold what month you're in, paycheck to hold the paycheck within the month, 1 or 2, the amount saved to start out, $50, and a grand total, which starts at $50. The basic work of the program is to output month and then a month number, for example, month 1, paycheck and a paycheck number, for example, paycheck 1 in month 1, and then a total. Then add $5 more to the amount saved for that paycheck, and then add the saved to the grand total. There's a loop that controls this output. To execute this loop, you'll set the loop control variable paycheck to 1, and then you'll see if paycheck is still less than or equal to 2 because there's 2 paychecks within a month. Then you'll add 1 to the paycheck and check again. While it's still less than or equal to 2, you'll add 1 to the paycheck number and check again. And when the paycheck number is over 2, you'll be done with this loop. You'll put all of that inside an outer loop that controls the months. The loop control variable for this loop will be month, and you'll start with month equals 1. Then you'll check to see if month is less than or equal to 12. While it is, you'll perform the output for both paychecks and then add 1 to month. And you'll continue this outer loop 12 times. So again, here's what the report looks like. Month 1, paycheck 1. Month 1, paycheck 2. Month 2, paycheck 1. Month 2, paycheck 2. And so on. Months controlled the outer loop, and paychecks 1 and 2 were executed within the inner loop. Thanks for watching.
Okay, so that is like the one that we did in class. The example in the book was the one on the quizzes, or the printing out a quiz sheet. And it had a nested loop. Oops, go to the right spot. It had a nested loop also, and that was on page 124 and 125. It showed you what the output was supposed to look like, and that was a nested loop that was on page 125. And so then she covered it again with a different problem there. Okay, anybody have any questions about nested loops then? So you can go back and watch that. I put the YouTube video of our lecture, I believe, up there, of the first part of chapter 4. And then in Evernote, I wanted you to do, oops, let's just go to your Evernote link. That'll be easier. Okay, so what I wanted you to do, find the Evernote link. There it is. Was chapter 4, problem number, where's it at? Week 7. Down here. Chapter 4, part 1, page 152, 1 and 2. So your assignment was to post that before today. Okay, so we could go over that problem, which is number 1. Okay, the exercises in number 1, did anybody that did those have any trouble understanding those?
Yeah, I wasn't exactly sure.
Okay,
I did the second question. The first one was.
that one on A, B, C, D, E, F, which
I was wondering if you wanted us to like actually pseudocode it all.
no, I just wanted you to give, okay, what is output by each of the pseudocode segments? It's already pseudocoded,
Yeah.
so I just wanted you to put what the output would be. Like, for instance, let's say, I'll do the hard one. Which one was, who did them all? Did anybody do them all? No? Okay. All right, so let's do D first. So we're going to go through D, and I'll do it here so it'll be on the video. We'll pull up Text Wrangler here and have a text box. Okay, so D says J equals 2, K equals 4, M equals 0, N equals 7. So it says while J is less than K. All right, so if we start this one, and we start out with J in the beginning, J is equal to what? 2. And so, and what is K is 4. Okay, K is equal to 4. And so if we say 2 is less than 4 is the first question, right? While 2 is less than 4, which it is, then M is equal to 5. So they changed M. So our very first step, M would be equal to 5. It would drop into that loop. While, then there's a nested loop, right? So now, while M is less than N, so right now, what is N? 7, and what is M? 5, okay? So is 5 less than 7? Yes. So the first output would be output X, right? M, now add 1 to M. So what's M going to be?
6.
Okay, so now M is 6. I don't want to put, let's see if I can do it this way. I'll just say, okay, next one, M is 6. And now it says end while. So it's going to go back to the one that says while m is less than n. That's the end while for that one. So now it's saying is 6 less than 7?
Yes.
Yes. So it's going to output x again, right? So there's going to be 2 x's on your output. Output x, and now increment m again. So it's going to be 7. So we test it again. Is 7 less than 7? No. So we're going to drop down to the end while, and now we're going to increment j by 1. So now j is 3. And so then it says end while, so I'm going to go back to that while where it says is 3 less than 4. Everybody see where I got that?
Yeah.
Okay, 3 is less than 4. Yes. So now I'm going to go down to where it says, let's see, while 3 is less than 4, then m is equal to 5. So I'm going to set m to 5 again, right? So I'm going to go back where m is equal to 5. And then while m is less than n, so what's n? 7. So is 5 less than 7?
Yep.
Yes. So output x again. Right? So I'm going to have another output. Actually, these words wouldn't be here, right? I would just have x, x, and another x. Okay, so I'm going to just take that out. Okay, so I have another output x. Now I increment m. So m is 5. So again, it is 6, right? So then end while, so I go back up, is m is now 6. Is 6 less than 7? Yes. So I output another x, right? And then I increment m again. So now m is 7, right? So now since m is 7 less than 7?
No.
No. So I'm going to drop to that end while, and so now I increment j again. So now j is 4, right?
Yeah.
Okay, so now I go back up to that while that says 4 is 4 less than, what's k? 4. So is 4 less than 4?
No.
No. So I'm going to skip down to that end while and output j, k, and m. So j is 4, right? And k is, I actually wouldn't put a comma there, and k is 4, and m is 7, and n is 7, right? Okay, y'all follow what you need to do?
Yeah.
Everybody see on all of those problems what you have to do. You don't write any pseudocode. You're just seeing if you can follow the logic through. Does anybody have any questions about what we did? Okay, so your answer to that would just be 4 x's and then 4477. That's what you should type in. You don't have to type where we went through it up here, but I wanted to do that so you could see what was in there at all times. That's a good way. That's called desk checking. Anytime you write pseudocode, you should do that because that tells you whether your logic is coming out correctly. All right? So who did problem? Somebody do problem 2? Okay, Robert did problem 2. Okay, so let's look at problem 2 then. Problem 2 says, design the logic for a program that outputs every number from 0 through 8. So am I going to have one loop or a nested loop? Why would you need a nested, Ronald? Are there two sets of no, just one loop, right? Like face it. So one loop, we just need one loop. Okay, so I'm going to take this out and I'm going to pseudocode it. Okay, so first thing we have our declarations, right? Okay, and so we're going to declare a num or var, whichever way you want to do it. Var, let's just call it number, okay? Var number. Is there any other values that we need? What else do we need? Anything else?
You can make it 0 or declare it.
Yes, declare it equal to 0, okay? So we're going to start off with the variable initialized and declared, which is one way you can do it. Okay, so now we want to input. Actually, do we need any input? Don't need any input from the user. All we need to do is what? While, oops, if I can type right. While number is what?
Less than
Yep, while number is less than 8. So now will it print out 8 if we say, because it says 0 through 8. Is it going to print out 8 if we say while number is less than 8?
No.
Yeah, it has to be less than or equal to 8. So let's see if that works. Let's try it. Okay, so what do we want to do while it's less than or equal to 8? We want to output number, right? And then what else do we have to do?
Add 1 to the number.
Right, number equals number plus 1, and then end while, and that's all there is to it. Now I didn't put a start of the program and an end of the program, but this should do it. So let's see if this works. So if I'm checking this, I've got number equal to 0, while number is less than or equal to 8, output number. So the first time through, I'm going to output a 0, right?
Yeah.
Okay, now I'm going to increment number. So let me put my values of number here. Number equals 0. And now I'm going to add 1 to number, so it's now 1. And so I go back up. Is number less than or equal to 8?
Yes.
Yes, yeah. Okay, so it output number, it's now 1. Increment number to 2. And now is number less than or equal to 8? Yes. Go down, it's now 2. So you can see it's going to work all the way up to, and I had to put the equal sign in there or it would have stopped at 7, right? Because let's try that. Let's go 3, oops, 3, 4, 5, 6. Okay, we just added 1 to number and number 7. And so I say, is number less than or equal to 8? Oh, actually, I've already printed it out. Now I increment it to 8, and I say, is number less than or equal to 8? Yes. And so that's how I would get the 8. Okay? All right, so that's the one that you all had to do for part 1. If you didn't do A, B, C, D, E, and F, go back and do those and submit them because I haven't graded them yet. Okay? Yes?
On the bottom part, you just check it. We just have to put the top part.
Yes. Yes. No. You just had, it didn't tell you to test it. I don't think I even told you to do JavaScript on that one. Okay, so there is, let me see, all of those first ones, 2, 3, 4, and 5, 6, none of those have nested loops. Those are just individual loops. Okay, so in here I told you for next Tuesday, March 11th, before class. Now, I want you to have this done and, I didn't, yeah, this one, page 153, pseudocode flowchart or JavaScript number 7A. All right, so 7 is going to be a nested loop. All right, so 7A only, and then we're going to do B. Wait a minute. Is it the nested loop? Oh, wait a minute. Company allows customers to purchase. No, that one's not a nested loop. B is the nested part. Okay, so you're not even having to do the nested loop on 7A, but I want you to get the pseudocoded flowchart and the JavaScript working on it. Now these up here, you only had to do pseudocode, okay, on number 2 that we did in class. All right, so then next Tuesday, we're going to go over the B part and put the nested loop in. All right. Okay, so anybody have a question about their assignment? Okay, so now we're going to go back and I'm going to try to finish the chapter today. So let's go to my PowerPoints, I hope. They are. This is chapter 4. And that is, did I put the slide number on there? No, I did not. Let's see about where that is. Comparison, incorrect logic. What is it called? Avoiding common loop mistakes. Okay, that's probably structure, continued, control variable. Definite with a counter. Let's see if I can find where we're at here. Sentinel. We did use a sentinel value, right? Using nested. Avoiding common loop mistakes. Okay, here's where we're at. Okay, so there are 4 common mistakes, if it comes up here. Neglecting to initialize the loop control variable. So you remember in the flow charts, initialize the loop control variable is saying if you have a value like in that example she gave us paycheck, she had to initialize it equal to 1 before she entered the loop, right? So you can't just declare it as num paycheck. You have to give it a value, okay? And before you enter the loop. So that's a common mistake that people forget to do. Neglecting to alter the loop control variable. So in the problem that we just did, where it was print out 0 through 8, if at the bottom of that loop we didn't increment number, then it would not have printed out all 8, right? It would have just printed the first one and kept looping. Okay, so using the wrong comparison with the loop control variable, which is what would have happened if we didn't put the equals, right? If we didn't say less than or equal to 8, then that would have been an incorrect comparison and it would have only printed out 0 through 7, right? Okay, then including statements inside the loop that belong outside the loop. So if we have a nested loop, that's going to happen more often than other times. But like, well, the initialize. Some people put that initialize inside their loop, and so every time it goes through, it's resetting the variable, okay? So you have to be sure that you don't include in the loop anything that doesn't need to be there. Here's some examples. Neglecting to initialize the loop control. So this example, it's always a mistake. It's over on page 127. Oh, wait, that's the correct logic. Let me go back and talk about the incorrect. Okay, it's always a mistake. Its uninitialized variables may contain unknown values in some programming languages. So that's the same thing that was happening on Robert's program before. We did not initialize the variable out. And so when he tried to print it out, it had an unknown in there, undefined. So not always will it cause you a problem, but just so you don't ever have the problem, it's best to always initialize your control variable, or any variables, actually. Program logic errors will occur. Figure 4-7 shows the correct logic for a greeting program, and figure 4-8 shows an example of a program where it's not initialized. Okay, so the correct one on page 127 shows that it prompts the user for a name, and while the name continues to be anything but the value all Z's, then the program outputs a greeting and asks for the next name. So you see what it does. It says it initializes up here at the top string quit equal to ZZZ, right? So in the beginning, it puts something in this variable quit, okay? And it says output enter name or quit to quit, right? Because if they enter QUIT in there, then it's not going to be the Z's, right? So they initialize it with all Z's, then input the name. So if they input a name, like say I enter DW, then is name not equal to quit? Okay, name not equal to quit. No, it's not equal to quit. So we would say, yes, it's not equal, output hello name, output enter name, or quit to quit. Input name and come back up. And so this one is a sentinel controlled loop, right? It's controlled by a specific value. Until the value is quit, then it's not going to stop. Everybody see that? Any question on that? So that one's a sentinel, not a definite loop. It's a sentinel controlled loop. So let's look at an incorrect way. Don't do it. Here, the loop control variable is not initialized here. It's not initialized there. They have a string up here, but in the previous one, they initialized, they put something in name. So up here, name's not initialized here, but it's initialized here. They're asking for the input name. But if we look at the one where the error is, there's nothing in name right here because we didn't put anything in name up here, right?
Yeah.
So there's nothing in name. So it would not work. Okay, mistake, neglecting to alter the loop control variable. Okay, so can cause a variety of errors, such as an infinite loop. Figure 4-9 provides an example of this common mistake. No names are accepted inside the loop. Okay, so this one is the one on page, is this 4-8, I think? Yeah, okay, this is the one on page 128. So here what happened is, oh wait, that's not the right one. Incorrect logic. Oh, that's still that one. Okay. What did I do? Is this the right one? Oh, that's the one we just talked about, right?
So this is it.
Okay, 4-9. Oh, this is 4-9. Okay. So 4-9 says, okay, don't do it. Loop control variable is never altered. So right here, after they output hello name, they don't ask for another input. So since they don't ask for another input, it's going to stay in an infinite loop and keep printing that same name. Yes.
So if we do accidentally run into an infinite loop when we're programming, will we be able to like just click the close button on our browser?
Yeah, or I think sometimes there'll be like a cancel or don't prompt again or something like that. Sometimes you have to close the browser window if you get stuck.
Thank goodness we're testing it with the browser
Yeah.
because Dad says.
Oh
computer
yeah,
will
your
crash if
computer.
you're not doing it that way.
That's right. When I used to code in procedure-oriented languages, it was bad because it would keep going over and over and over, and I'd get called in the middle of the night, and the program's been running for hours, and it's not outputting anything, and so had to go find out where it was at. Okay, so the next one is correct operators and operands must be used. Could also result in wrong number of loop executions. Figure 4-10 shows an example. Oh, goodness. Okay. So this one is figure 4-10, and that's over on page 130. So in this one, the wrong comparison, instead of saying not equal, it just says if name is greater than quit. Well, you can't compare an alpha character to greater. You can't say it's greater than. Okay, so that won't work. Including statements inside the loop that belong outside the loop can cause a program to perform inefficiently by unnecessarily executing the same code numerous times. So here demonstrates an inefficient way to produce 100 discount stickers for items. Inefficient because new price is calculated 100 times even though price hasn't changed. Okay, so 4-12 shows the improved method. So in this one, which is 4-11 on page 132, you see what happens. Down here, after they get into the loop that says sticker count is less than stickers, whilst if it's less than stickers, this program works, but it is inefficient because the same value for new price is calculated 100 separate times, even though the price has not changed. So new price, you can see down here, you come here, output, here's where they input another price here. But up here, if sticker count is less than stickers, so on the next one, it's going to show us how it should be. Actually, that's the pseudocode for it, not what not to do. And the next page shows us the right way. If we say new price equals price minus price times discount, in this improved version of the program, the new price value is calculated just once, and then 100 stickers are output. Okay. Now, there's a review. If you want to review over these and see how the author explains them, she has a video, and I'm not going to show this one this time, but when you're at home, you can do this one, avoiding common loop mistakes. Okay, anybody have any questions? All right, so we're going to go to a for loop. A for loop is an alternative to a while loop. You normally don't use both. For loops are used when the program knows exactly how many times the loop will repeat. You can do that with a while loop also, but most normally when you're using a counter, you will use a for loop. There are 3 actions in one compact statement, so it's a lot more efficient loop for a counter-controlled loop because you can put all 3 things right in that one statement. It initializes, evaluates, and alters the loop control variable all in one statement. Otherwise, you remember in a while loop, you have to initialize it above, then you test it, and then down in the loop, you have to increment it, right? Mm-hmm. Okay, well, in a for loop, you do all 3 of those things in one statement. We'll look at it. For statement looks different in various languages, but basically, here's what it does. These are 3 possible ways to write the pseudocode to display hello 4 times using for and while loops. So here's the pseudocode for a while loop that displays hello 4 times. You initialize the counter to 0. Then you say while count is less than or equal to 3, output hello, and then you increment counter here. Okay? Now, if you're using a for loop, look how much shorter it is. For count equal to 0, 2, 3, step 1, output hello. That is saying, and that's an N for. Okay, that's Visual Basic style. Here's pseudocode for Java, C++, and C#, which is also the way you do it in JavaScript. For count equal to 0, semicolon, count is less than or equal to 3, semicolon, count plus 1. That's what plus plus means. You can say count equals count plus 1, or you can simply say that's called the shortcut way, count plus plus. If you wanted to decrement, you'd say count minus minus. Okay? Output hello in 4. So you see how many more statements it took here. So if it's a counter-controlled loop, you know exactly how many times you're going to go through it. It's wiser to use a for loop. Does that mean this is wrong? No, this isn't wrong. It's just that this is a more efficient way to do it, okay, is using a for loop. Anybody have any questions about that? Does that make sense? Okay, step value, the amount by which the loop control variable changes after the body executes, and it can be positive or negative. It does not have to be 1. Step value example displays hello 4 times. You could say 4 count equal to 12, 2, 6, as, and step -2. Now, there really isn't any reason to do that for this problem, but it's just showing you for a simple example that you can start, you can initialize count to anything you need it to be. You can say go down to 6, step -2, so it's still going to print out 4 times, right? Because it would start with 12 and it would print hello the first time, and it's already then it's already subtracted 2. So the second time it's going to be 10, it'd print, then it'd print at 8, and then it'd print at 6, right? Common loop applications. When do you ever want to use a loop? These are the common times, and one of them the author already did in that nested loop, an accumulator. But every computer program is different. There are various applications that use similar techniques. Loops can be used to accumulate totals or validate data. So using a loop to accumulate totals is what the author did in that nested loops, right? So you can go back and watch that video if you want to see one of the uses. For example, business reports often include totals. Report of total value for real estate properties sold in the last month. The accumulator is a variable used to gather or accumulate values during repetitions. So all it is like a variable that holds a value. Every time you repeat something, it's putting that value in that total. That's called an accumulator. Okay? Must be initialized prior to entering the loop, and the value added to the current value during each repetition. The value is output at the end of processing. So you want that total at the end. So on that one, she was accumulating a total for a savings, right? And so each time that total was added to, and at the end, the final total was printed out. So here's an example on figure 4-15 in your book, which is 140. Okay. So this is actually it's 39 has the flow chart, and then 140 has the pseudocode. But they're both on that same page. So whichever you like to see better. Let's look at the pseudocode, because we haven't looked at any of the pseudocode. So here what they did is there's the flowchart and pseudocode for the real estate sales report program. They have a string address, num price, num accumulate equals 0. And it's really important that your accumulator variable, that you initialize it to 0 so that you know there's nothing out there, okay? Nothing is in there that was stored in memory at the location that the computer's using in memory to store that variable. String heading 1 equals month-end sales report. String heading 2 equals address and price. String quit equals all Z's. And that actually, last time I said that wrong, because what it's doing is it's initialized at all Z's, and it wants something else in there to quit. So output heading 1, output heading 2, output enter address of property, input address. While address is not equal to quit, output enter price of property, input price. Output address and price. Accumulative value equals accumulative value plus price. So we're going to accumulate the price of the properties as long as the user doesn't enter quit, right? When the user says, hey, I'm done entering property prices, I don't want to accumulate anymore, then they type in quit. And what you'll have to remember is in JavaScript, it has to match exactly. So it has to be all uppercase. Okay, output, enter address of next property, input address. So here's the one that's at the bottom of the loop. And after you drop out, after address is equal to quit, it's equal to all these to start with, right? So as soon as the user enters quit, instead of entering an address, or down here is where they're entering after the loop starts. When they enter quit, then it goes to end while, output total, accum value. Okay, so that's a good use of a loop because it's going to repeat until we're done entering values there. So using a loop to validate data, let me see, this one is the last one. So it's defensive programming. It prepares for all possible errors before they occur. You can use loops to validate data. You can make sure data is meaningful and useful. It could involve checking data type or range. Here's an example program where the user enters a birth month number. The possible actions if input is less than 1 or greater than 12, then it's not a valid number, right? Because there's only 12 months. Display error message and stop the program. Assign default value for the month before processing. Reprompt the user for valid input. See figure 4-16 on the next slide. Okay, so here what they've done is they've said output, enter birth month, input month. If month is less than low month, which is a constant, 1, or month is greater than high month, which is 12. If it is, then you need to ask for them to enter another month, right? So it's just looping there. Limiting a reprompting loop is the last one. It can help ensure invalid data may frustrate and annoy the user if it's continuous. Good programming practice is to state the valid values in the prompt. So when you're asking the user to input something, you need to say input the correct address or quit in whatever you want them to enter to quit, right? You need to, in your prompt, always say the options. Or what some of you have done is good is you put it in that box, what the options were, like mahogany, oak, and pine when we had that one. You put it in the box so that they know they have to enter one of those 3 values. Okay, limit the number of attempts. Force the override the input to a specific value after a certain number of attempts. And example, figure 4-18, here it is. Here's the example of one that limits the number of times the user can input the month of their birth. And then these are some things that are functions that are part of JavaScript. You remember some of you have looked up that toFixed function. These are examples of functions in JavaScript that you can check to see is numeric, and you would put the variable name in the parentheses, and that's already coded. It's a little coded function that you don't have to code. When you use it, JavaScript knows what it is character, is white space, is upper. There's one that says upper to lower too. There's a function called, it'll say is upper, then there's to lower. So if it is uppercase, you can use the function to lower and it will change it all to lowercase. So there's a lot of neat functions that you can find in JavaScript and Java and all of them. Okay, validating reasonableness and consistency of data. Good programming practice to validate data, and those are things that you'll learn as you start writing programs more, is that when a user inputs, you want to validate it. Say, hey, is it, if I told them to put quit in all uppercase, I can say is upper, okay? There's ways to test it. Compare zip code with city, compare date of purchase and date of payment. If customer's title is Miss, gender should be F. Okay, so when your assignment then before Tuesday is to have 7A coded and JavaScript also. And if you have problems with the JavaScript, there is also in here under the content, you remember I put Dr. Singal's book. Where is it at? Here it is. And let me show you repetition, structure, or looping. So here he shows you in this PDF, if I can get it to come up, he shows you a loop, and he also down here at the bottom should show you the JavaScript for the pseudocode. While, expression, loop body, there's some things that he does. Is that it? Initialization, pretest, update, and loop. Okay, let me see. Somewhere he has a chart, or he usually does. Okay, here's a loop. There's how you would code it in JavaScript. And there he tells you about it. There it is again. There's examples, event controlled, flag controlled. I thought he shows you matching pseudocode. Let me go. Some of his problems are kind of, there it is in Dreamweaver. If you have Dreamweaver. Okay, those are the tags that you can use. I thought this was the one that had to fix. If it's stuff that we haven't covered, don't worry about it. Just skip over it and use the part out of here that's helpful to you. I was trying to remember. I thought it was right in here. But I still don't see where he has that pseudocode. He does it in selection. There's a big flow chart opening. Oh, he's showing in here how to do a table. Don't worry about a table. That's kind of tough. Where loop shoes, blah, blah, blah. Is that the one? No. In one of them, I think it's the selection one, he shows a line of pseudocode and then the JavaScript. But that one wasn't it. But it does explain loops more and more in there if you want to look at it. Or remember those two places. Amelia gave us a site that her dad gave you. This one called JavaScript Sites. And then I gave you the W3 Schools here also. So both of those will help you find functions and ways to code things. Okay? All right. See y'all next time.
Are the chapter videos still posted in the D2L? Because I don't see it in the chapter video.
Yes. Let me see here. Stop